Good morning, students. Today we're going to be focusing on balancing chemical equations. The law of conservation of mass states that atoms cannot be created nor destroyed during a chemical reaction. Therefore, when balancing an equation, the coefficients must be used in order to set the number of atoms equal to each other. A solid technique is to list all atoms on each side along with how many there are. Then multiply the coefficients until both sides have an even number of all atoms. In the next slide, we will begin to practice.
You have to list the atoms on each side of the reaction. So we have carbon, hydrogen, and oxygen. As you can see, we have listed them on both sides of the reaction. So as you can see, we multiplied the carbon dioxide by 3 to match the 3 carbons on the reactant side, and the water molecule by 4 to match the 8 hydrogens. Since the oxygen changed on the product side, we multiplied the oxygen element by 5 to even out the number of oxygens on the reactant side. Here is how the equation would look.
So if we put calcium chloride with silver nitrate, we get silver chloride and calcium nitrate. However, this chemical equation is not yet balanced. As you can see, we listed the elements from both of the reactants and product side with how many atoms each side has. For this specific equation, we need to have the atoms of nitrogen, chloride, and oxygen be equal. So again, we multiply each of these elements by the lowest whole number ratio.
You guys should start to get the hang of balancing chemical equations. Let's do another one. This is a synthesis equation, where if you take oxygen gas and phosphorus trichloride, you'll end up with phosphoryl chloride, or POCl3. Try not to look at the solution. This is what you should have gotten by multiplying oxygen and phosphorus on the product side by 2, as well as multiplying chloride on the reactant and product side by 2. One last problem. This is a decomposition equation where if you start with hydrogen peroxide, you get water and oxygen gas. Without trying to look at the solution, let's see if you can balance it. And there you go. You should end up with the equation below.